So hi everyone, we're back. We're here to teach now about normal equation. This is a part three of our
Series about linear
linear
regression.
regression. Yes, and as Diego said in the last video, this is just about you, one single step you to find the best parameters of theta, and that will make our work really easier. But here we use some linear algebra and calculus to find them easily. So first, what we have to do is represent our data as matrices. The first part is our x and theta matrix. These are multiplication factors, and where x times theta will be our age of x. This is just a different notation, and but it's pretty the same thing that we saw in the first. And here I explain a little of where this all of this comes from.
Guys, just a quick addition. You see the transpose of the values of x, and you have to do that in order to be allowed to make the matrices multiplication. That's why you make the transpose. Without the transpose, we couldn't multiply the values of x because of the dimensions. If you already studied a little of linear algebra, you know that there are certain requisites that you have to obey in order to make some matrices multiplication. That's why you make the transpose.
Yeah, that's true. So we have a simple rule here that x transpose times x is equal the summatory of x squared. And this is basically what our linear function is, our cost function is, I'm sorry, that is the h of x, that is this one here, that is x of x theta, multiplication,
Multiplied by theta.
yeah, and plus
Minus.
the y,
Minus y.
and square. So we find that this part here is the part of our j of theta, our cost function.
You guys can check that by yourselves, making some matrices multiplication if you want.
Yeah. So we end up that the cost function, this is the normal, just with numbers.
The same equation that we saw in the last video.
And transforming it to matrices, this is gonna be our value. G of theta is going to be like 1/2 of this thing here.
So you're just applying the formula that we defined here in our cost function, so that we end up with this.
Exactly. So, and in order to find the best parameters, as in our gradient descent part, we have to derivate j of theta with respect to theta to find the best parameters.
Yes, because if you guys studied already calculus, you know that in order to minimize any function, you have to derivate it and make it equals to 0, so that you're going to minimize that function. And the cost function is basically the difference and between the predicted numbers and y, our true numbers. So we want that to be as little as possible. That's why we derivate and make it equals to 0.
Yeah, and we use this following notation that is the gradient of j of theta. That's the derivative of theta related to j of theta. Each theta related to j, and we have that this is equal to this one, and we oops.
Oh no.
Yeah, and after derivating this function, we and make it equals to 0, we end up with that theta will be equal to x transpose times x inverse times x transpose y.
Guys, and here there are a lot of algebra here, and this is not simple, this is hard. This is a very strong algebra exercise, and we're not going to explain that deeply here, but what normal equation tells us is that you can find the theta only knowing the x and the y. And this works only for linear regression, for nothing else. In machine learning, if you try to do this for an SVM problem or a non-correlation problem, classification problem, this is not going to work, okay? Only for regression. And guys, this is all this math and algebra is just to say, well, we have a formula to find theta, only knowing x and y.
Yeah. So this is just a lot of matrices manipulation, and we already have the values of x and y in this equation. So we only need to find the x transpose and x transpose times x inverse. The inverse of this is here.
And I'll show the code in this video. We would make it in another video, but yeah, we can do this right here. So basically, we are using the same data set that we made up previously with x1 and y1. And we already know the x's that are the inputs that we have. We already know the y that are the outputs. So in order to know the theta that we need, we just have to make a lot of matrices multiplications. And here's the code, and it's not a hard code. Basically, you have to transform everything in an numpy array, as I said, and we already did this with x1 in the code here before. Where is here? We already transformed x1 in a numpy array. We have to transform y1 also in a numpy array. We have to create this matrix of ones just because remember that we have that dummy feature.
Yeah, the x0
always equals to 1. So we have to concatenate this line of ones. That's our theta 0 x0. That's basically 1 with our input of x's. So this is basically all the code that we have. We have to create this ones vector, and we have to concatenate with the x1, and we just have to code those formulas. Basically, we have to code this. So x transpose in Python is really easy using NumPy because we only have to check here, but dot t, it's the transpose. So we have our matrix of inputs, and the transpose of it multiplied by itself, it's just this transpose multiplied by itself here, and it's this here, and we use this code matmul that makes the matrices multiplication. We cannot write a transpose multiplied by a because those are matrices. You can't do normal multiplication of them. You have to use this function matmul. That's basically math multiplication. So we already have this one. That's basically the x transpose multiplied by itself. That is this part. And we make the inverse of it. That is also pretty easy in Python and NumPy. We have to use this inv stuff
for inverse.
Yeah, for inverse.
You link all that is from linear algebra.
Yes, it's a function of linear algebra. And well, and this is for y, okay, and this is for y that we have to make is this part here, second here, x transpose multiplied by y. So x transpose multiplied by our y, and the theta is the multiplication of those two that we just discovered. So this code is going to be on the description of the video, so you guys don't have to remember. You can check it by yourself. And well, Just making those algebra and calculus, we can find the data that we want in normal equation. And I printed them and compared them. They are just the same from the linear gradient descent that we just made. So that's it for this video. And in the next video is going to be really fun because you're going to apply all the knowledge that we built until here in a real data set. It's gotta be a lot of fun. Bye bye.
Bye.